Hello and welcome to Dr. T's Math. In this video I'm going to solve some simultaneous equations in a couple of different ways using graphs by substitution here and then with matrices. So first I'm just going to solve this equation in terms of y, solve for one variable in terms of the other, and then we'll substitute that back into the second equation. So moving the 3x over the other side, then dividing by 2, we're going to get 2y over 2 is equal to 1/2 minus 3/2 x, and then we're going to substitute this value of y into this equation. We get 4x plus 3 times 1/2 minus 3/2 x is equal to 2. Carry out the distribution here. You get 4x plus 3/2 minus 9/2 x is equal to 2. And then just combine like terms. 4x minus 4.5x is negative 1/2 x. And then take this 3/2, bring it over the other side by subtracting. 2 minus 1.5 is 1/2, and so then x is equal to negative 1. And we're going to take that value of x and put it directly into back into the first equation. So we get 3 times negative 1 plus 2y is equal to 1. Oops, sorry, I solved that one. Let's put it back into the other equation here. That'll be better. So 4 times negative 1 plus 3y equals 2. Negative 4 plus 3y then is equal to 2. Move this over there. We're going to get 3y equals negative 2. And then, negative 2 times 4. Negative 2 plus 4. 2 plus 4. And then 3y is equal to 6. Y finally is equal to 2. So those are our two answers there. Y equals 2 and x equals negative 1. Let's go over to the TI graphing calculator here. And unfortunately, the graphing calculator won't easily let you put things into standard form. So we've got to go with these y equals form, or the mx plus b form. So we've got y then is equal to 1/2 minus 3/2 x. And then the other one here, we're just going to take the x, put it over the other side, change the sign, and then divide by the coefficient of y. You get y is equal to 2 over 3 minus 4 over 3x. So those are our two equations, 1/2 minus 3/2 x. And I'm just going to put it in decimal, 1/2 minus 3/2 x. And then the other one, I have to put this one in fractional form, 2/3 minus 4/3 x. 2/3. Make sure to put your parentheses into the TI calculator as often as possible because of order of operations. It really bungles up some things. So I've got my two functions in there, and then I'm going to graph, and we'll see where does it intersect at. In fact, there we are. Oops. Negative 1 and 2, and so that confirms negative 1 and 2 right there. So that's the first way to do these, or that's two different ways to do these. Graphing is certainly faster, right? And then it's more precise. Like if you're dealing with non-whole number intersection points, it's way more precise and faster. There's a lot less potential for error. But let's look at another way to solve these. Imagine you just put these into a matrix. So we had 3x, 2y equals 1, and then 4x, 3y equals 2. So just put those into the matrix, and we got x, y, and then equals, this is whatever it equals. And what we're going to do here is put it into row-reduced echelon form. So the first one I'm going to do is take R2 and subtract from that R1. And so R2 minus R1 is going to be, the top row stays the same, but 4 minus 3 is 1, and then 3 minus 2 is 1, and then 2 minus 1 is 1. Next operation, I'm going to take R1 and subtract from that 3 times R2. And so I got a 1 here. I'm going to use that to get a 0 up top, and then I'll switch the rows. So we got 3 minus 3 times 1 is 0. 2 minus 3 times 1 is negative 1. 1 minus 3 times 1 is negative 2, and then the bottom row stays the same. You can combine row operations in one combination, but I find it easiest to just do one at a time. Now I'm going to switch R1 and R2. Now remember, you can multiply any row by a scalar, you can switch any rows, and you can multiply any row by a scalar and add or subtract it to any row when working into row reduced echelon form, which is going to give you your solutions. Negative 2. So I just swapped these two rows here. And then I'm going to take and multiply row 2 by negative 1 in order to turn that negative 1 positive. The top row stays the same. The bottom row just changes sign. And finally, last step, I'm going to take R1 minus R2. So 1 minus 0 is still 1. 1 minus 1 is 0. 1 minus 2 is negative 1. And we got 0, 1, and 2. And so row reduced echelon form, the first entry in each row is a 1, and then each column thereafter is zeros. But I put this little line here because that's where our equal sign is. And so our solution for the simultaneous equations is negative 1, negative 2. And in fact, we can confirm both on the graph and in the previous slide where we did substitution that is the answer. Let's see how to do that a little bit faster with the graphing calculator. Now I've got it in landscape mode here, so we can see a whole bunch of extra commands on the left, but still math is there below alpha, and then you can see matrix underneath the x to the negative 1. So I'm going to press second and then x to the negative 1 and get to the matrix menu. Your first option menu is the names, and the names are not really consequential. I'm going to go over to edit. I'm going to edit, this one is B. Probably already got it kind of set up. So we got 2 rows and 3 columns, and then indeed we got 3, 2, 1, and then 4, 3, 2. Remember when we can do some matrix math later. But remember, when you're setting up your matrix, your rows are first and then your columns are second. In this case, indeed, we've got 2 rows for simultaneous equations or systems of equations, and then 3 columns, 1 for x, 1 for y, 1 for what it equals. And you can imagine that this is the x column, that's the y column, and then that's the equals column. So I'm going to quit and then go back to matrix, go to math, and down here at number 0, which is number 10, letter A, row reduced echelon form. Letter A, let's try that one. Row reduced echelon form, and then back to matrix. I'm going to have to go back over to the names, and this one was B. I'm just going to close out my parentheses just in case. And there we are at 1, 0, negative 1, 0, 1, negative 2, same as all those steps there gave us the same thing, but it's way faster to use the calculator, just like it's faster to graph. So the calculator is essential on something like the ACT when time is of the essence. Okay, this has been Dr. T's Math. Thank you for watching.